Hey, how are you doing? Chrono here, and in this video we will start working with procedural generation. We'll be using rule tile and 1D Perlin noise to generate our upper layer of our procedurally generated world. If you want to know how to make a proper rule tile for your procedural generation, then the link is in the description down below, and all the blogs and videos from which I learned about this topic is also in the description down below. So with that said, if you like the video, smash the like button. If you love it, then don't forget to subscribe and share it to anyone who wants to learn about this as well. So with that said, let's get on with the video. Now to start our procedural generation, let's make a game object called procedural generation and put a script that is also called procedural generation. Now then, let's open it up, and at the top write using Unity engine.tilemaps so that we can use our tile map. Then in here let's have an int called width and height, which will be the width and height of our procedurally generated land. After that, let's have a tile base called ground tile. This is the place where we will put our rule tile. Then a tile map called ground tile map. Now let's hit save and back in Unity. You'll see 4 places to put values. In the width, put 65, the height 30. We will put our ground tile. I have it here. Ground tile, you can download it from the description down below, or if you want to make a perfect rule tile for your procedural generation, then there's a video in the description down below. So let me just drag and drop this here for the ground tile, and for the ground tile map, let's just create a ground tile map. So in tile map, let's call it ground tile map, and then drag and drop it here. Once that is done, now this is like a brush, the ground tile, and the ground tile map is like a canvas. We can have specific values in there, right? For example, if I add a tile map collider, meaning every tile now I create inside this ground tile will have a specific kind of a collider. And this is how we can set different types of tiles. Let me just remove all of this, I guess. So now after we do that, let's just go back to Visual Studio. And let's have an int called map, which will be a 2D array. And you can make a 2D array by writing something like this, int, and you'll have a comma in the big bracket, and that's a 2D array called map. Now in the start function, write map is equal to new integer of 2D array, in which we'll have width as the x value and height as the y value. Now this map array is like a grid of integer in which we have width as the x value and the height as the y value. And let's say if both width and height value was 10, then a grid which looks something like this would be created with a width of 10 boxes on the width, and height of 10, so 10 boxes on the height. And in each of these boxes, we can put any kind of an integer value, like 0, 1, we could even put 2, 3, or so on. So now in this procedural generation script, what we will do is, first of all, we'll make a function that will fill all of these boxes with zeros. Then another function which will fill it with ones in a procedurally generated height value, but which will be actually lesser than the total y-axis or the height value. And after that, we'll have another function that will put nothing in places of 0 and put our ground tiles in places of these 1, giving us a procedurally generated land. And then we'll have a logic which will be like, if the zeros are inside the area of 1s, then put a cave tile on them. And we'll do exactly that. So this is a short description of what we are going to do in these upcoming videos. Now back to Visual Studio. Let's create a function called generateArray, which does the first thing, which is create zeros in our map. So write public integer of a 2D array called generateArray, and inside this array we'll have a width value, so an int width, and an int called height, then a boolean called empty. Just follow along for now. And inside, first write int, which will be a 2D array int, map is equal to new int with width for the x-axis and height for the y-axis. Now we want to go through the width of this map, and we'll do that by using a for loop. So write for int x is equal to 0, x is less than, and here we'll have width, and x plus plus. So this will basically go through the width of our map. So inside it, let's do the same thing for the y-axis as well. So make another for loop where int y is equal to 0, y is less than height, and y plus plus. Now what will happen is when we're looping through the width, meaning until x is equal to the width value, as well as when we're looping through the height, meaning until y is equal to our height value, what we will do is we'll just ask if it is empty, meaning if empty is true, then our map on that particular x and y value, meaning x comma y, will be equal to 0. Else our map on that same x and y will be equal to 1. Now I can write it a little bit more elegantly, I guess, by just writing it something like this. So map x comma y is equal to, and inside a bracket write empty, meaning if we are empty, and write a question mark as well. If we are empty, then put 0, otherwise put 1. Once I do this, basically this line of code and this is the same thing. So I'm going to use that. Essentially what's happening is we will basically loop through all of the x and y value of the map array and then put zeros or ones according to our boolean into that map array value. This we will set when we call it here, okay? So that is what we're going to do. It is saying something is wrong. The reason why is we have to return something here, return an integer. Basically we need to return our map here. So here just write map, so return map. Now let's have a function that puts tiles in place of those zeros and ones. So write public void render map. And this render map will take an int, this will be a 2D array called map. It will take another value called tile map, which is our ground tile map. Then let's have a reference to the tile base, tilebase, tile base. This will be our ground tile base. So once we do that, inside again we want to loop through the width and the height. So let me just copy this. And we don't need to do this, so let me just remove this and write if our map on the basically x comma y value is equal to 1. So wherever in the x and y coordinate of our map we have a value of 1, for example like this, right? Wherever in our map grid, if we have a value of 1, we'll just put a tile in that position. So we'll basically now, if we have 1 in those positions in our map, then in the real world we're going to put a tile in that same position. How we'll do that is basically write ground tile map. So ground tile map dot set tile, and inside a bracket write vector3 dot position. We need a vector3 integer position, so write new vector3 integer, and for the position we're going to have x comma y comma 0 because we don't need anything on the z-axis. And then for the tile, now we need a tile base, so for the tile it will be our ground tile base. So now once we do that, let's just call both of these functions in the start function. First of all, remove this, and after that write map is equal to generate array, and basically for the width put our width from up here, for the height put our height from up here, and for now keep the empty as false, meaning it is not empty, and if it is not empty then we'll have 1 there, because I want to show you this map getting rendered as well. So keep it as empty and then call our render map function. So in the render map function what we need to do is we need a map first of all. So write map for our map, this map. Then we need a ground tile map, which will be our ground tile map here. Then we need a ground tile base, which will be our ground tile. Once we do that, let's go into Unity and hit play, and you'll see tiles are being formed according to our procedural generation. And because I had kept it as false, we got a 1 in each of those places of our map, and wherever we saw 1, we just spawned a tile on that place. So that is exactly what's happening. If you want to see one more thing, let me just remove this and write true this time. That means it will be empty. Remove this and hit play, and nothing gets spawned now, as you can see. So everything is working fine. If this is happening to you, everything is working fine. Now, in Visual Studio, we are going to make another function that will generate our terrain. But before we do that, at the top here, just below our width and height, have two floats, in which one will be called Smoothness, and the other one will be called Seed. Smoothness handles the smoothness of our procedural generation, basically, and Seed will help us create different kind of generation according to the seed value. Now after that, let's make our terrain generation function. So just above our render map, create public int, which will be a 2D array, called terrain generation. And inside we will take in an int, which will be our map. Now after doing that, inside let's create a int called Perlin height. Then again we need to loop through the width and height. So let's copy and paste it from here. And then just remove this if statement. Now, before we loop through the height, what we first need to do is write Perlin height is equal to mathf.Perlin noise. This helps create a gradually increasing and decreasing kind of a height value, but with the help of our values from here. So the values we are going to keep is for the x-axis, it takes in two values, by the way, float x and float y. For the x value, keep x, which is this x. But now for Perlin noise, what we need to do is we need to have at least one point value, meaning a value below 1, right? We need to have at least 1 point value. And because we are going to use x as well as seed, so the seed sometimes will not be a point value, and x will definitely never be a point value because x is an integer. See, integer never goes into a point value. So what we need to do is just divide this by smoothness. What happens is, by doing this, we're just like killing two birds with one stone. We are also bringing a smoothness effect into our Perlin height generation, as well as giving a point value, which helps us create a perfect Perlin height that will gradually increase and decrease. Otherwise it won't work. What will happen is it will just find one value and keep on having that value, and that does not help. So we need to do that, and finally we need to just multiply this value with our height. So once we do this, it still says something is wrong, so put it inside a small bracket, put the whole thing inside a small bracket, and then we will round it into an integer. So before doing that, the reason why we're getting this problem is that we are trying to put a float value inside an integer. This guy is an integer. This gives a float value. So best thing to do is basically to round it into an integer. So write mathf.round to an integer. Once we do that, let's just have a semicolon here. Once we do that, our job is done. Now what we will do is instead of looping through the height, we'll loop through the Perlin height here. So we'll loop through the Perlin height of our map, and in every value of x and y until we reach our Perlin height, we'll put 1 in our map. So map x comma y will be equal to 1. And let's just return this value. So return our map, and once we do that, everything is done. Now all we need to do is basically just call this function up here just before our render, and everything is done. So write map again is equal to terrain generation, and inside we need our map value, and we are done. Now whenever I'm playing it, I want to keep on tweaking the values and see what works properly, right? So for that, what we can do is in our update function write if input dot get key down space, meaning basically whenever we press the space key. So whenever we press the space key, what we want is we want to call a function called generation. So void. So we want to call this function. So here in this generation function, first of all, what it does is that it will basically clear out our tile map, right? First of all, it will clear out our tile map. We'll do that by writing ground tile map dot clear all tile. Once we do that, all we need to do is we need to call all of this from here, then call this from here. And once you do that, every time I press the space key, this generation algorithm or function will be called. Now, once we have done that, let me show you something. So if I just go here, now for the smoothness, one tip, never keep it as 0 or 1. If you keep it as 0, it will be infinite, and I don't think it will probably spawn anything. If you keep it as 1, it will only give one value, because now there won't be any point value. We need to have a point value, so at least you have to have 2 here. But I would recommend it keeping at the same height value. Got it? Once we do that, let's just hit play. And now you have procedurally generated 2D terrain with your tile map, which is awesome. Now, let me just try and change the seed value. Let's put some, I don't know, legendary numbers, I guess. And as you can see, the world gets generated a little bit differently. If I put, I don't know, another legendary value, and the world gets generated a little bit differently. If I increase the smoothness just above our height, what's going to happen is the world gets a little bit more smoother. If I keep it below our height, a world gets a little bit more jankier. And that is all that's happening. But I don't want to keep this generation like too high. I want it to keep fairly flat, right? For that, what I need to do is just go here, then basically divide our height by 2. Once you do that, hit save, go back. And if I hit play, so now it gives a really flat looking procedural generation, but now the height is too low. All I need to do to solve that is just go here and write Perlin height. We'll add that with our height divided by 2. Once we do that, we'll have this flatness because of this. By the way, if you want, you can have a value called height reduction or something like that, right? And put it here. Maybe you can even tweak that value and bring out a little bit different kind of a procedural generation. Don't keep it here, but for me, this looks fine, all right? What's going to happen is basically this will make a flat kind of a procedurally generated terrain. This will just increase the height of that overall terrain. Basically, whatever value we have it here, we'll just add the total height divided by 2. Once we do that, if I just hit play, now you have the height as well as you have this kind of a generation. And by the way, try tweaking the smoothness. You know, gives you a really, wait, let me show you kind of weirdly. Yeah, gives you a really weird kind of a generation, which looks kind of cool. So that is it for this video. Thank you for watching. In the next one, we will start working on the cave generation. For that, we have 2 methods. One is with Perlin noise and the other is with a neighbor system or cellular automata. So stay tuned, like, share and subscribe, and have a great day. Bye bye.